Hello everyone, my name is Afan, and today we're going to do some more derivative proofs. So if you watched the last time I did a derivative proof, I believe I proved why the derivative of ln x is 1 over x. So again, today we're going to do some more proofs of derivatives, because I feel like in calculus courses what happens is that you get a lot of derivative formulas thrown at you, you only get a couple proofs, and they kind of expect you to figure out the rest. And yeah, you can, basically. The information they give you is enough for you to figure out the rest, but it's always cool to see where some of the formulas come from, because we don't always have the time to derive every single derivative formula, we just kind of take it for granted. So the purpose of this kind of series that I'm doing is just doing some simple derivative laws we know and just looking at them and seeing where they come from. So today what I'm going to do is I'm going to basically derive some of the really simple trigonometric derivatives. So I have a couple in front of me that I have derived in front of me, and I'm just going to share them with you and show you where they come from. So let's do the first one that we all know. So I'm going to do tangent is, I was going to show tangent, but I noticed that tangent is shown in a lot of textbooks where the proof is shown. So I'm not going to prove tangent. What I'm going to do instead is I'm going to go prove cotangent, secant, and cosecant instead, if that is a little bit different than what we're used to. So yeah, I believe I have it right here. Yeah, okay, I do. So we're gonna start off with cotangent. What we're gonna do is just basically do the proofs of the reciprocal trigonometric ratios. So let's do the proof for cotangent. So if f of x is cotangent x, well, we also know then that f of x must be cosine of x over sine of x, right? Because tangent is sine over cosine, cotangent is cosine over sine. So if we know that, then let's go ahead and take the derivative. Alright, so I'm using this, by the way. So I'm going to use the quotient rule. So basically we're going to have a huge line here. So we're going to have sine squared x, right? Because the bottom gets squared. We're using quotient rule. And now I'm going to use the quotient rule, low d high minus high d low. So low. If you haven't heard this is pretty cool. So low, and then derivative of the high. So derivative of cosine is negative sine. So negative sine x minus high d low. So high is cosine. So cosine. And high d low, so derivative of the low, is going to be cosine. Alright? So you can see where I got that from, where I got this from. So now if we make this out to be, so this would be negative sine squared x on the top, right? Sine times sine, negative sine squared x, minus cosine times cosine, well that is simply cosine squared x. There we go. And on the bottom, I have sine squared x. And that's all there is to that. Oh, I'm looking there, I'm supposed to be looking at the camera. Okay, that's all there is to that. And if you know the Pythagorean identity, which is cosine squared plus sine squared equals 1, well then negative sine squared minus cosine squared is negative 1. So what we're going to have instead is negative 1 sine squared x, right? And if you remember what negative 1 over sine squared really is, well, you know negative 1 over sine squared is simply cosecant. Yes, it's cosecant. So, no, 1 over sine squared is cosecant squared, but since we have negative 1 over sine squared x, the derivative is simply negative cosecant squared x. Alright? So you see where we get the derivative of cotangent x? Well, it's simply negative cosecant squared x because we proved it right here, and it's really not a hard proof. So just seeing, where this comes from makes it a little bit intuitively easier when we're taking derivatives normally. Alright, we've proven cotangent x, let's prove another one. Again, this is not something difficult to do, I'm just showing it to you guys because not everyone has the time to go prove these by hand. So if you want to just look at how they're proved. So okay, so we did cotangent, let's do cosecant next. So cosecant x. Well, what is cosecant x? Cosecant x is 1 over sine x, right? 1 over sine x. Great. I always mess up cosecant and secant because they're always, a little bit weird in the brain. But okay, cosecant is equal to 1 over sine x. We know that. Okay, so let's go ahead and take the derivative. So f prime of x, well, what I'm going to do is I'm going to use the product rule instead of the quotient rule. I'm just going to bring the sine of x up. So 1, and I'm going to have sine of x here to the power of -1. I just brought it up. You'll know what I'm doing. Now all I do is apply the chain rule. So I'm going to bring the -1 down front. So -1 here, sine of x here, and this becomes -2. Raise the power, lower the power by 1. Sorry, I was talking about integration. And take the derivative of the inside, which is cosine. Great. So now we know that the top, all we have remaining is negative cosine x, and on the bottom we have sine squared x. Hopefully you can see where I'm getting that from. There's nothing too difficult here. And the way we get the proof is I'm going to break this apart, alright? So I'm going to have -1 over sine here, -1 over sine x, multiplied by cosine x over sine x. Alright? All I did was I took this and I rewrote it as -1 over sine x and cosine of x. If you multiplied this, you'd get this right here. And if you take a look at this, you'll see that -1 over sine x is simply equal to cosecant x, or negative cosecant, my bad. And what's cosine over sine? Well, that's tangent, cotangent, not tangent. So cotangent x. So this is the proof right here. So the derivative of cosecant x is simply negative cosecant x cotangent x. If I am not mistaken, and I'm not mistaken, this is the correct proof. So let's prove the last reciprocal ratio, and we'll call it a day for the proofs. So hopefully you can see where this comes from. Okay. I believe the only one I have left to do is secant x, which is not too hard to do. Let me just get rid of that. Okay. So now we're going to prove secant of x. Alright, so what is secant of x? Again, we don't deal with secant of x, we're going to deal with this instead. Secant of x is simply 1 over cosine of x. Right? Okay, so let's go and take the derivative. It's really the same process again. So f prime of x is equal to, well, let's bring the cosine of x up. So we're going to have 1 cosine of x, -1. Okay, so let's take the derivative of that. Well, let's bring the -1 up front. -1 cosine of x. Oh, that looks pretty bad. I'll rewrite that. Okay, so we're going to have -1 cosine of x, because I brought the power up front. Lower the power by 1, so -2. Take the derivative of the inside, chain rule. So that's going to be negative sine of x. Alright? You can see how this went to this. Okay, so I have a negative in front of the sine of x, and then I have a negative here. So what I'm going to do is just going to write sine x up here, because the negatives cancel out. And it was cosine x to the power of -2, so let's bring that to the bottom. So we're going to have cosine squared x. And again, if you know where I'm going with this, you'll know what I'm going to do. I'm going to break it apart, have 1 cosine of x here. Right? I'm breaking it apart, multiplied by sine x over cosine x. Right, I just broke it apart, so if I brought these together and brought this together, I would get this. And if you take a look at it, this is the same thing as secant, so secant x, multiplied by sine x over cosine x, well that's tangent. Let me just verify that is correct, and that is correct. So secant, the derivative of secant x is simply secant x multiplied by tangent of x. And I believe those are the 3 reciprocal trig ratios, and the derivatives of those reciprocal trig ratios. So again, this was really not an advanced video. If you've done a little bit of calculus, you know where I'm getting this stuff from. The purpose of this video was just to show you where we get it, because usually the only proofs you get are cosine, sine, and tangent, so that's why I didn't show tangent. But usually those are the proofs you get, and these are just given to you on the formula sheet, or they just tell you to memorize it. So now I just showed you through this video where the derivatives of these actually come from, and it's really not that difficult, as you can see, just simple derivative operators being applied. Alright, so hopefully that video helped. I hope to do some more derivative proofs, because I love doing these types of videos to show where different types of things come from that we usually don't take a look at. Alright, so if these videos help, please subscribe and hit the like button. The first time I said that. It does help the channel and help me make more videos. So again, hopefully you learned something, and I hope you have a great day.